This video is my reflection for Unit SYS 202 System Software. Over the past few weeks, I have been learning about how operating system work, and in this unit I want to share what I have learned and what was hard for me and what I got through it. It will also explain why this matters in my career in digital forensics. My name is Upadesh Sai. I'm a student of Kent Institute, Australia, and for the week one, it was all about operating system, and we started with a simple question: what is an operating system? Before this unit, I thought like it was just a software that makes a computer run, but I quickly learned it was much more than that. The operating system is basically the manager of your computer. It controls everything: memory, processing, file managing, devices, and also it does all through the four main managers: the memory manager, processor manager, device manager, file manager. Think of it like a restaurant kitchen. There are different sections, and for different sections there is the manager in the different parts. So every manager has their own specialty and one task to do. So to come into the week to come into week two, what week two was really a challenge because like we covered the operating system, how operating system handles memory, specifically it's called paged memory location. It was a little bit difficult to understand, but I will give a simple analogy that I use, which made me very easy to understand this concept. So I think of it like a car park with number spaces. A program you open is like a car that needs to park. Instead of needing one big empty section, the car can put into different parts of that car. The car park can put different parts of that car in different available spaces, and it keeps a map of where everything is. That map is called the page map table. I also learned about virtual memory, which is when the computer pretends it has more memory than it actually does. It only loads the parts of program that it needs right now and leaves the rest on the hard drive until it is needed. The topic was difficult at first. I had to work through the maths examples a few times and draw my own diagrams before I understood it. But once it clicked, it felt really easy. So about the week three, it was all about processor management and scheduling. It was more about theoretical and very like deep concepts. The week three was how operating system decides which program gets to use the CPU in what order. This is called CPU scheduling. We learned three different scheduling methods. The first, FCFS, which stands for first come first served, is exactly what it sounds like. Whoever arrives first gets processed first. Simple, but not always efficient. So, the second method is called shortest job next, SJN. Lets the smallest job go first. It is like a supermarket express lane. If you only have two or three items and the person in front of has a trolley full, it makes sense for you to go first. And this is really efficient. And the third one is shortest time remaining is even more smarter. It can stop a job midway if a shorter job arrives. It is more complex but faster overall. The tutorial exercises which where we actually calculated the turnaround times made this very real for me. Seeing the numbers change depending on what method you use showed me that these decisions really matter. In digital forensics, understanding how a CPU is used or misused can be a key evidence. So for the week 4, it was about deadlocks and processor synchronization. We talked about what happens when program gets stuck waiting for each other. This is called a deadlock. The lecturer used a great analogy to explain it. Imagine a staircase that is only wide enough for one person. Two people meet in the middle and neither one wants to back down. They both are stuck. This is called deadlock. The whole staircase, the whole system stops working. This is also something called a live lock, which is even more trickier. That is when two people on a landing keep stepping to the side to let each other pass, but they keep mirroring each other and neither one actually moves forward. The system is active, but nothing is getting done. We also looked at real examples like two programs trying to access the same files at the same time and the two processes locking database records that needs. For digital forensics, this week was especially useful when I investigated a system crash or system failure. I know now how to look for the signs of deadlock. That knowledge could be a difference between solving a case and missing the cause entirely. And about the week 5 was week device management. Week 5 covered how the operating system manages physical devices, things like printers, disk drives, and USB controllers. I learned that different devices fall into three types: dedicated device, used by one program at a time; shared device, used by multiple programs at once; and virtual devices, dedicated devices that are made to act like shared ones, like a printer that handles jobs from multiple users through something called spooling. I also learned how the operating system manages the flow of data and from devices through input output traffic controller, input output scheduler, and input output device handler. Three layers of that work together to make sure everything runs smoothly. From forensics perspective, understanding how drives store and retrieve data and how RAID systems spread data across multiple disks is directly relevant to recovering digital evidence. This week gave me a practical knowledge I can use in the field. And looking back at these 5 weeks, I'm genuinely surprised by how much I have grown. At the start, I saw an operating system as a black box. Now I understand the logic behind it, the managers, the algorithms, the trade offs, the things that can go wrong. The biggest challenge for me was the calculations in memory management and scheduling. My strategy was simple: slow down, draw it out, and work through every example step by step. This approach really helped me. More importantly, I can now connect everything that I have learned to my goal of working in digital forensics, whether it is understanding how memory was used, why a system crashed, and how data was stored on a drive. This unit gives me the foundational knowledge to investigate and explain those things properly. Thank you very much for watching my reflection. I'm looking forward to what comes next in this unit.